Hi, my name is Harvey Villanueva, and this is my course project for Stat 503. 530. So recently, Elon Musk decided to buy Twitter, and the whole thing has been a hot, heaping, steaming dumpster fire. He's like laying off thousands of people daily, and then all of a sudden he realizes they're kind of useful, and then he's been rehiring them back, and it's just been kind of a mess. And then there's that whole verified incident when all of a sudden people, if you just paid $8, you can get the verified check mark. And then we're now ripping in peace Jimmy Fallon because apparently he died. I don't know. Rest in peace, Jimmy Fallon, I missed you. So of course, now that Dr. Hitchcock has finally given us the ability to choose whatever data set or whatever database we could possibly imagine, I decided now with this freedom, let's analyze the dumpster fire. So the extraction process was actually kind of simple to use. It was the SNS scrape package in Python where I extracted the 10,000 most recent tweets. But I had to make sure these tweets were of some high quality. I wanted, garbage in, garbage out. So I filtered to make sure that these tweets had the following qualifications. Number 1, they had to be in English because it's only really funny if I can understand it. Number 2, I filtered out all tweets that had image links because image links are really hard to analyze from a statistical perspective. And finally, number 3, I filtered to make sure that every single one of these tweets had 1,000 likes, 1,000 replies, and 1,000 retweets. This made it so that I didn't accidentally scrape some tweet from a bot, because there's actually a ton of Twitter bots that post like random crap all the time. There's a bunch of people who's like advertising their SoundCloud and trying to get big on Twitter. And there's a bunch of like OnlyFans creators that are posting adult content online. And I wanted to make sure I got none of that. So I made sure that they had to have 1,000 of each of those counts. And blam, here's some pseudocode. But no one likes looking at code. Only losers like looking at code. We're gonna skip on ahead. And with that, I had 10,000 tweets under my belt and I trudged forward. In addition to the 10,000 tweets, for every single one of the tweets, I also took the amount of likes they had, the amount of replies they had, and the amount of retweets they had along with them. And you might be wondering to yourself, oh, but Harvey, we didn't study anything about semantics and textual data. We didn't study anything about anything other than not numerical data. And to that, you're right. I genuinely did not have an answer to this for like a good month while dreaming up this project. But then I found a solution. Enter LIWC 2015, which stands for Linguistic Inquiry Word Count Analysis. Or, for the sake of shorthanding it, I want to call it Luke, just like my favorite Jedi. So Luke takes advantage of natural language processing and supervised machine learning to analyze text for specific qualities. For example, if I had a variable that was all about positivity, and I had a sentence that was, I'm so happy, it'll probably flag the phrase, so happy, as like a really high mark and give it a very high positivity score. But for something like, I want to die, it will flag the word die as a very negative word and give it a low positivity score. Some limitations that come with Luke is that a sentence like, I'm so happy I could die, will probably be flagged as a neutral positivity score. But that, in essence, that's all it is. It analyzes a text, it reads it, it looks for specific words, and based on its dictionary that's stored into the software, it gives it a score on whatever variable it was analyzing for. So I took the Twitter content that I scraped, I shoved it into the LIWC, or the Luke, and it outputted a bunch of variables for me to look at. Those being the variables that are showing up on your screen right now, but for the sake of me not wanting to take up a whole bunch of your time, I'm not gonna go through all of them, but just know there's a ton of variables. And now it's time to big data this B word. Can't say that word. Nope, no way. So looking at the data, I'm realizing I have 65 variables. God bless Luke, but I'ma be real, 65 variables is a lot. If only there's some way I could figure out a way to reduce the amount of variables, but also keep the information that's hidden within the variables. If only I learned some sort of technique in class. So after running the principal components analysis, I was able to reduce the 65 original variables we had to only 26. That represented a cumulative 70% of the total variance, which is pretty good. A 65 to 26 is pretty good. And while I do say that that was, successful, I'm not gonna put you through 26 components and explain and interpret every single one of these components, because that's a lot of time. But I found, according to the scree plot that I'm going to show right now, an elbow kind of occurs at the third component mark, and so for the sake of simplicity, that's what I'll be going with. I'll be going with 3 components for now, although I do understand it's grossly underestimating the total, variance, but for now, I'll go with 3 components. Let's talk about them. Principal component 1 loads heavily on the analytical tone and has negative loadings on function words, pronouns, and present tense. Because of this, I will call this the component of factual statements, or the components that are much more about facts and logic. Principal component 2 loads heavily on clout, emotional tone, social processes, drives, and affiliation. I will call this the party time component because it's mostly just people, having a good time. Social events, clout, drives, all those type of things. And finally, for principal component 3, it has negative loadings on I pronouns, affection processes, negative emotions, anger, biological processes, and sexual topics. And since this topic has a bunch of negative loadings on these topics, then I will call this the anti-negativity or the positivity component. And graphing these together, you see this mess. Principal component 1 and principal component 2 have like huge globs and clusters of data around the 0, 0 mark. And I looked at the bivariate density plot, and it's true. There was just a huge glob of data right there. And then I was like, okay, you could maybe kind of try to figure there could be a linear relationship, so I ran a correlation test and found there is not. The correlation value is almost close to 0. And the same can be said with PC1 and 3 and also PC2 and 3. It's just a huge glob of data at the 0, 0 point with no real trend or pattern within the principal components. I even tried some multi-dimensional clustering that we learned in chapter 6, and of course it led me nowhere because it's just one big cluster at that one point. And part of this could be attributed to the fact that it wasn't a good representation of the data as a whole, and it didn't make up a good proportion of the cumulative variance. But nevertheless, I got nothing out of the principal components analysis, and there were no real patterns, nothing to show for it. But that's just the nature of statistics, all right? It's like being a ship at sea, a pirate at sea. Sometimes you run into abandoned ships, sometimes you ran into already looted treasure chests, sometimes you run into dead ends, right? But that's okay. That's just the nature of statistics. We're here to explore. And you know what? Maybe we ran into a dead end. Okay, maybe we should try factor analysis. Maybe factor analysis will bring us something. I don't know. I ran the factor analysis with k equals 30 factors, and I had a p-value of 0. Even when I rotated the data, I still had a p-value of 0. And when I tried 31, it said 31 was too much. I'm gonna be real. I can't even perform the factor analysis because the amount of factors I have is not sufficient. The factor analysis has brought me nowhere. Back to the drawing board. We're gonna do it the good old-fashioned way. No data reduction, none of this principal components analysis or factor analysis, just pure raw data. Let's just look at the raw data, okay? Let's just do it from there. Here's a visualization of the correlations within the data. The darker the shade of blue, the more positively correlated, and the darker the shade of red, the more negatively correlated. No, I don't want you to squint at the screen. I did the squinting for you. Here are some notable correlations that I found within the data. Pronouns and analytical tone had a negative correlation of negative 0.63. This actually is kind of cool, and it kind of makes sense because as the number of personal pronouns that you say increase, the less likely the tweet will be about analytical factual observations. Tweets that have like really high pronouns, such as like storytelling tweets, are less likely to be analytical, which I think was like a cool little piece of information. The 3 tweet counters that I originally extracted, the count of likes, the count of replies, and the count of retweets, were all positively correlated with each other. That is, if a tweet had a large amount of likes, most likely it's also going to have a large amount of retweets and a large amount of replies. Which kind of makes sense. That's how virality works. And I guess the Twitter algorithm is making sense. These had a correlation score of usually between 0.5 to 0.8 with each other. Affection and positive emotion had a positive correlation of 0.85. This is kind of a no-brainer. Of course, if you show more affection, more loving, and more liking in your tweets, you're gonna have more of a positive emotion in your tweets. This one's just kind of a no-brainer. This was kind of cool. Drives and affiliation had a correlation score of 0.78, and affiliation and social had a score of 0.68. Whatever your drives are and whatever your social environments are, that's what you affiliate with, even when you're on Twitter. But what I found was the most interesting was the lack of correlation other variables had with the virality tweets. Your like count, reply count, and your retweet count had no other variables that were correlated with it, which was extremely interesting. I was looking for some sort of pattern, but there was none. But of course, me being me, I wanted to dive and dig even deeper into it. So the predictive methods we learned in class, I wanted to figure out a way to predict the amount of likes a tweet gets. More specifically, if it has these type of variables, if it has this type of positive emotion, this high of negative emotion, this type of affiliation, and this type of power, what would the like count be? But more importantly, I wanted to figure out what are the most important variables in a tweet that attribute to its like count. How do I get Twitter famous? Before it inevitably shuts down because of Elon Musk and wherever the heck Elon is thinking of, I want to be famous. I want to go Twitter viral. How do I do that? With the regression classification tree, I was able to produce this tree that you see in front of your face. It seems to maximize the amount of likes on a tweet, which is all the way to the right. One needs to increase their mention of money and biological processes. In order to minimize the amount of likes on the tweet, which is the category all the way to the left, don't post a lot about money and don't post a lot about work. But more importantly, by this regression tree method, money, work, biological processes, and affiliation are the most important variables for a tweet's like amount. And with the random forest method though, I found a little bit of a different story. The most important variables for tweets for the like amounts are money, words per sentences, 6-letter words, and eclectic participles. So if you want to get a bunch of tweets, the most important variables to consider are money. And make sure to keep your tweet tight and succinct. Tweets with a ton of big boy words tend to do very poorly. That's what I found. On the other hand, tweet variables that are of low importance, or at least things that you tweet topics that you shouldn't really consider a lot if you want a big like amount, are female related terms, sexual topics, she/he, pronouns, and family. For these variables, they play a small role in determining the amount of likes your tweets get. So post away, don't really think about those. Those don't really matter. And with that, I'm done. Quick, direct tweets about money and biological processes will probably get you a ton of likes. There's a present correlation between affiliation drives and social environments on Twitter. There's a negative correlation between pronouns and analytical tone. But with that, I'm done. And I hope you learned something from this. Anyway, after all that, here is a picture of my dog. For no real reason, I just wanted to show you my dog. My dog symbolizes me after I finish this project and I crash for the remainder of Thanksgiving. Thank you so much for watching, and I'll see you in the next one. That was a very YouTuber. Why did I do that?